Welcome at the Rijswijk Centrum for Sustainable Geo-energy. Today I would like to introduce some colleagues who are working on the development and testing of innovations related to wells in the subsurface. So my colleagues will briefly show what they're working on and what equipment they're using.
This is a fully operational drilling rig with a hole of 400 meters below it, where we can run tests for various drilling equipment and also geothermal equipment. So I think it's a really nice piece of equipment that's actually quite rare in the world to have open for use for tertiary parties. Here we have the opportunity to just have smaller companies and also still the big ones if they want to do tests that are all otherwise unavailable for a lot of people.
So right now we're standing right in front of the wells underneath the rig here in our lab. The wells would target for different projects and different applications. One of the particular wells is a project I'm involved on where we'll be testing novel composite materials. These materials are more sustainable and they have a lower carbon footprint than traditional materials used for wells. So here we're going to do this research project where we'll be testing the functionality, the conditions and the work with these novel materials.
So behind me we see the cuttings flow loop and here we conduct experiments to research the cutting transport process during a drilling operation, and in this case for shallow geothermal energy. So what happens is that we have water which is constantly flowing through the flow loop, and during that flow we add extra cuttings. By doing this we can see the different behavior of the cuttings during different conditions during a drilling operation.
In the background we have built an experimental setup that can be used to analyze the performance of a borehole heat exchanger. And borehole heat exchanger is a part of a ground source geothermal heat pump. Inside this setup we have replicated a borehole heat exchanger system.
Behind me we see the biggest hydraulic press that we have here with a maximum capacity of 400 metric tons. The 400 ton is needed to simulate the similar conditions as according into the subsurface. It's special because it's a lot of force of 400 metric tons.
Behind me is so-called 50 tons drilling machine, where we test and develop novel geothermal drilling technologies. The uniqueness of this setup is that it can recreate the conditions found at 2.5 kilometer depth by controlling the pressure, the flow, and also we can change the different rock samples that are being drilled and expected at this depth.
In order for the energy transition to work, we need the subsurface.